Hey everyone, so this is my wrap-up video for both weeks 2 and 3. So I didn't post a wrap-up video last week, so I am covering both weeks 2 and 3. In a moment, I'm going to go over to my keyboard, go over a couple of the questions or comments that came up in knowledge checks 2 and 3 for the past 2 weeks. And then I'll also go over the solutions for the first assignment. I've posted the grades and comments for that, so the solution file is posted for that. I go over that in a moment. So let me switch over to my keyboard, go over those things. I'll see you on the other side. Okay, just a couple things came up in the knowledge checks for weeks 2 and 3. For week 2, where we were looking at the loc command as well as some profiling, the biggest thing that came up was there were some people that expressed a little bit of confusion over whether to use brackets or parentheses. Okay, so the square brackets versus the parentheses. Okay, and that is the most common confusion that comes up at this point in the course. I think that by the time you get to week 3, some of you in your comments from the knowledge check for week 3 started saying that this was making a little bit more sense. So I do think the more you use this stuff, the more it makes sense, or the more it sort of just becomes a little bit more second nature, okay? A lot of this is practice, but the best way I can explain it is this. So we're using parentheses whenever we're using a function. So for instance, let's say that I'm looking at df. So here I've got the stock data. Let's look at stock shares. So df stock shares, okay? And if I wanted the mean of that column, well, the mean is a function. It's actually doing some work. Someone had to write a function, someone had to write code that basically adds up all the stock shares and then divides by 7859 to get the average, okay? So the parentheses are typically used whenever we're using functions, okay? Where that confuses people is when we start using loc. So let's say that I'm looking for any row where stock shares is greater than 500, okay? And it turns out everything. So let's go to 1,000. Okay, yeah, so the original data has 7860 rows. This is only showing 3406 rows, so it's any row where the stock shares is above 1,000, okay? Now, notice I'm using square brackets here, and people get a little confused because they feel like loc is similar to a function, okay? And so they're kind of confused as to why we wouldn't just be using parentheses here instead of square brackets, okay? And the best way I can explain this is loc is really not a function. Loc is literally locating data, okay? It's pulling data from the data frame. It's not transforming the data in any way. Now we can do something like this, you know, we can do this, and anywhere where it's over 1,000 for the stock shares column, you know, I could take df stock shares plus 1, okay? And that would actually change the data so that now when I do this command, let me take this out just to get it where it was, okay? If we compared this to what I just had a moment ago, all of these now have 1 share more than it had previously. So there I used like an equal sign, an assignment statement to actually change the data. That transformed the data. But the loc command on its own doesn't change the data. It's just locating data. And the best way I can explain this is it's the same thing as saying df stock shares with brackets, right? So I showed this to you like in probably week 1, maybe week 2. This stock shares, I'm using square brackets to access this column. It's not changing the column, it's just locating the stock shares column. And I use square brackets to do that. Well, that's what loc is basically doing. But loc allows us to locate data for a kind of a filtered view, right? So I can specify column and row criteria so that I don't get the entire data set. I don't get all 7860 rows. But here I can kind of filter. In this case, I'm filtering only to get these 3406 rows, okay? So loc feels, when you first learn it, it feels like a function, but it's not. It's not transforming the data. It's locating, it's pulling out the data in the same way that when I do DF stock shares, I'm pulling out that column. Okay, so that's kind of the best way I can explain that. Logically, that's really what's going on here. But again, if that's not making a ton of sense to you, then here's the other mnemonic. Loc uses square brackets. It's the only thing that feels maybe like a function that does not use parentheses. Okay, so you just need to remember whenever you're using loc, you're using square brackets. Okay, someone had mentioned a little bit of difficulty with case sensitivity, and just a reminder, it is case sensitive. Okay, so you just have to, and this is similar with R. They're no different from R. Many computing languages are case sensitive, so it's just annoying when you get errors like that. But just try to pay attention to the error message, right? So in this case, whenever you get an error message, always go to the bottom line. This bottom line typically kind of gives you information about what's going on here. This isn't particularly descriptive, because it's just simply saying stock shares key error. What a key error means is this thing it can't find. It can't find this key in the data file. So whenever you have a key error, that's kind of telling you, hey, check your spelling. Check your spelling. There's something wrong here. Okay. Someone had mentioned, so let me do this, df.describe, and here include equals all. I showed this to you early on. This is the describe command. But if you want to include the categorical variables, so like ticker symbol, statement, in this case, ticker symbol, date, and statement are the only ones that are kind of showing as categorical or strings. And someone had mentioned that they're not seeing top bottom. I actually don't have top bottom. So for the categoricals, I have unique, top, and frequency. And just to remind you, unique just means for this categorical variable, how many unique categories are there? There are 60 different ticker symbols. Top means of those ticker symbols, what has the most frequency? In this case, the ticker symbol CAT. And then frequency just means for that top category, how many rows are there with that category? There are 148 rows. For the person that mentioned that this is showing up differently, reach out to me. So if you try to do this and this isn't showing up, unique, top, and frequency, please reach out to me. Give me a screenshot or give me your script, so I can kind of check the code and see. But you should be having unique, top, and frequency. Again, I don't typically use describe when I'm profiling a categorical variable, because I don't think that that's very useful, right? If I want to look at ticker symbol, let's see, ticker symbol. And in this case, I think it's ticker symbol. Is it all? Yeah, it's all lowercase. I probably want to use value counts. Okay. Oh, and look at me. I'm using the wrong brackets. I don't know why I did that. I was using the weird braces, the curly braces. I think this is a better way to do this, because now I can actually see all of the categories with their counts, and they're sorted from high to low. Whereas if you do this in here with include equals all, include equals, oops, I'm having a hard time typing today. It really doesn't give you the full information, right? I mean, it tells me there's 60, but it only then tells me about cat. It doesn't tell me about like what's the second, what's the lowest. It's hard to kind of see that I've got some that are capitalized, some that are lowercase. You can't really tell that from using describe. So I actually don't like using. I showed this to you in case you want to use it, but I kind of usually keep that off. I typically just do describe and use that to summarize my numeric variables. Okay. Someone had asked the question, particularly when it comes to feature engineering, because a bunch of you mentioned that you really enjoyed learning about the fact that you can square a variable to take away any quadratic curvature. You can log a variable to get rid of the effects of skew. And so the question was, is there a point at which you start changing your data so much that it invalidates your analysis? And absolutely, that's always the risk. Okay, so the feature engineering that we're doing is we're trying to get our data to fit the model better. But there is a point at which you could start changing things so much, so drastically, that now you're just getting models that are really strong on really, really, really changed data. And now they're kind of divorced from the reality of the data. Okay. And of course, our models are always an abstraction of reality, but we want our models to reflect reality. So I would say there's a balance here. There's a balance here. I can't kind of give you like a numeric measure of when you've gone too far, right? This is part of the art of analysis, is exploring, trying things, being creative, but also trying to be grounded in reality and recognizing that there is kind of a balance there. What I often tell people, like in my undergrad class, where we do a lot more of kind of feature engineering and working with advanced modeling techniques, the one thing I kind of tell them is, try it different ways. Try your model without the transformation and then try it with the transformation. Test things out and then compare your results. And so, for example, if you build your model and there's a relationship between stock price and stock shares in the raw data, and then you transform one of these and you're still seeing a significant relationship, that actually strengthens your argument. So sometimes when you run the model multiple ways and you're still getting consistent results, that actually kind of strengthens the fact that there's something there. And if you're getting very different results, then it's really up to you as the analyst to kind of think through, well, what is probably more reflective of the reality of the situation. And what I would always say is kind of, if you're giving a presentation to a group, keep that in your backup slides, right? You may have questions. So if you don't present the data transformed, someone might ask you that question. Well, hey, that variable is highly skewed. What happens? Do you think that skew is really affecting your analysis? And then you can go to your backup slides and say, aha, well, I tried it with the log and I actually got very similar results. Okay. So the point is you want to try that as the analysts and see what happens versus not having tried something, being in a meeting, presenting your results, and someone kind of springing that on you and you not kind of having an answer to that question. So I would say in the feature engineering modeling process, be creative, try different things. But yes, you want to be cognizant of the fact that there is a balance, right? That you can go too far. Okay. And once you go too far, so for example, when people are dealing with curvature in the data, I think it's very common for people to square a variable to get rid of a quadratic curve. Even cubing. So cubing is if you've sort of got a curve like that. But when you start like, raising things to the power of 4 to the power of 5, or if you try to log something that you've squared, now you're getting into such complex transformations that you really are kind of getting far away from what the actual underlying relationships probably are. Okay, so yes, there is kind of a balance there, and I think that that's a really important question. People enjoyed kind of getting into OLS linear regression in Python. I hopefully that brought back memories from DA1, where you learned how to do all that stuff in R. Just a reminder, when it comes to the exam, I'm only, in terms of the inferential modeling, I'm only testing you on OLS linear regression. So if you watch those optional videos, you may have kind of gone through the stuff that I talked about when it comes to logistic regression. Let me see if you kind of keep scrolling down here. There's a section on logistic regression, as well as Poisson regression, which are regressions used when your y variable is different. I'm not going to test you on that. So by all means, if you're interested in this and you haven't watched those videos, they are available in Canvas, but I'm not going to test you on that stuff. Okay. I typically do test during the regular school year, but in the summer, our schedule is so condensed that that I don't. I'm trying to be cognizant of how much material you're trying to capture in a 6-week course, which is very different than a 14-week course. So just be aware of that. Now, someone did ask, are there ways to do stepwise regression? So in DA1, you learned about stepwise regression, which is doing an OLS regression where you just throw all the variables in and then it kind of does this stepwise loop to find the variables that are most significant, have the most significant relationship with your y variable. I'm not covering that here because we're not in this course. We're not using linear regression for prediction, so that's really useful if you're using it basically as a way to do machine learning. And I would say that there are machine learning techniques using linear regression that will do those sorts of things. Um, but we're not covering linear regression in that context. We're using it really for inferential modeling, which is I want to understand relationships between these variables. I'm looking at this scatter matrix, and I want to kind of understand the relationships that exist theoretically. And so I find that stepwise regression is very atheoretical. It's very much throw everything in, see what happens. You may have overfitting there. When it comes to inferential modeling, we're not really correcting for overfitting. We are truly just trying to understand, does this thing relate to this other thing? And if so, what is the relationship that exists? So stepwise regression is not as helpful for that. But there are techniques for stepwise regression. And again, I would just say, as with anything when it comes to Python, AI tools are really great for coding. If you're curious about that, go over to like Copilot or ChatGPT, and given a data set, ask for it to kind of give you code that would allow you to do some stepwise regression. It'll probably lead you astray from what we've done, however. So the packages we're using don't make that easy, but there are other ways you can do that. So by all means, I encourage you to explore that. Okay. In terms of the actual questions on Knowledge Check 2 and 3, Knowledge Check 2, I think for the most part, people got the questions right. For Knowledge Check 3, let me come over here. For Knowledge Check 3, I've got the student view on, so let me see if let me take the quiz here just so I can see the questions. I think that where people lost some points was when you started getting down here, right here at question 5, 6, 7, where you started doing some more heavy duty feature engineering. In particular, question 6 and 7, I noticed a lower percentage correct. And what I would tell you is just to remind you, and I kind of gave you the hint here, that whenever you're doing feature engineering where you're changing your data, if you've done something wrong, so when you're kind of here working on stuff, if you do something wrong, like for let's see, up here, did I already? Yeah, let's see. Stock shares. Let me turn that back to a lowercase s. Okay. If you remember a few minutes ago, I did an assignment statement where I added 1 to all of these stock shares. I've now changed that data. And so let's say that was a mistake. I didn't mean to do that, or I shouldn't have done that. Well, the problem is I've now changed the data. So how do I fix this? I actually have to come back up here, reload the data, right? And when I reload the data, okay, before those were all 1017, they're back to 1016. And now I can make my changes. And so what I think probably has happened when you get to questions 5, 6, and 7 is if you did something in your feature engineering process that was incorrect, if you didn't come up here and reload the data from scratch, you're now working off of changed data. So you're kind of compounding the errors, which means you're going to get slightly different answers. Okay. So really important to note that whenever you're doing feature engineering, if you mess something up, you're going to have to come back up here and reload your data. That's the value of working with scripts, by the way. We work with scripts so that when we mess up, we can just start from scratch and quickly reload, fix the script and then reload and rerun all of the commands up to that point. That's the nice thing about having a script. Okay. The last thing I'll kind of talk about is I've released, let me continue. I've released the grades and comments for assignment number 1. And so just to show you, if you go back to the assignment in Canvas, if you scroll all the way to the bottom, you'll see the solution. And so let me just quickly go over this to make sure we're all on the same page. So people were able to read the data in. In terms of the data types, people were able to run the code. The code was not the problem. But some of you didn't mention that date is really inaccurate. Okay. And actually, I'm just noticing this solution file is from last semester. I need to rerun this. So I will repost this because I think for you all, this is probably now showing up as a string instead of an object. It's the same difference, but the point is I did want you to point out that really that's not the correct data type for date. Date really should be read in as like a date time object, okay, not a string. Let's see, when it comes to profiling rented bike count, I did specifically want you to give me a measure of center and spread. When it comes to a measure of center, either the mean or the median is fine. When it comes to a measure of spread, either the standard deviation or the IQR is fine. Now, to be clear, if you're going to give me the IQR, it's one number. So a few of you gave me like the range. You said, it's from 192 to 1066. That's the range, but that's actually not the IQR. You have to do the math. The IQR is a single number representing that middle 50%. So I did deduct for that. Okay. And then given the fact that the median and the mean are different, there is some skew, okay? In terms of rainfall, what are the concerns? There were really two things I was looking for. The first is that we've got a lot of missing variables or missing rows when it comes to rainfall. If you look at rainfall, the minimum value is 0.1, which means that this is saying every day it rained. Well, that's not realistic. What's likely happened here is these missing values are really zeros. Okay, so that's one thing I wanted you to point out. The other thing is that there's a huge max here, 35 millimeters. We go from 2.5 millimeters all the way up to 35 millimeters. I mean, that would be a huge rain day. So that's clearly an outlier, probably something, some sort of data quality issue there. Okay. In terms of questions 7 and 8, I was looking for you to use code from the course. In particular, value counts is probably the easiest way to get to these answers. You could have used LOC. Some of you used code that's outside the scope of the course. So some of you did filtering without using LOC. That's not something we covered. And so just to be really clear, when it comes to the assignments, when it comes to the exam at the end of the semester, I'm grading you based on code that we've covered in the class. So where this gets a little tricky is when it comes to the assignments, I have allowed you to use AI. So I'm not disallowing the use of AI. Now on the exam, you cannot use AI. But for the assignments, you can use AI, but you got to be really careful. Don't use AI to simply don't just copy and paste this question over and ask AI to answer this for you. It may give you code that differs from what we covered. I think AI is best used to help you if you get stuck. So if you run code and you're getting an error message, or you're running the code from the course and you're running up against some block, then AI, I think, can be very helpful to get you unstuck. But I would not use AI just simply to copy and paste questions and have it give you the answer. Because first of all, it's going to give you code potentially that differs from the class, and so you'll lose points there. There were people that lost some points for that. Secondly, you're not learning, right? I mean, the part of the point of this class is to learn some basic Python. If you're just simply having AI code for you, you're not truly learning Python. You know, and while I do want to acknowledge the fact that AI can be really good at coding, as the connections exercises try to point out, coding with AI when you don't have a base of knowledge can be very risky. And so the point is, I want you to learn some foundational things in Python so that after this course, you can then use AI to code, but you've got a foundation upon which to build so that you can check the code that it's giving you, or you can kind of see that it's not really answering the question that you're looking for. Okay, so that's kind of the point. When it comes to the contingency table for the question 9, you had to include margins to get the totals. For question 10, I wanted the relative percentages out of the total, which means that you needed to do normalize equals all. Some of you did normalize equals index. A couple of you did normalize equals columns. Normalize equals index gives you the percentage out of the row totals. Normalize equals columns gives you the percent out of the column totals, but we want out of the total percentages out of the total, which is normalize equals all. Okay. Visualizations, for the most part, people got these right. So I think those were the things that were a little tricky. Okay. Just to remind you, so let me come over here. Everything's basically posted for the course except for the final exam and the practice exam that I will post in the next couple days. So just to remind you, for this upcoming Monday, Knowledge Check 4, Assignment 2, and Connections number 2 are due. Okay. But you can work ahead. Knowledge Check 5 and Assignment 3 are already posted. If you've gone through next week's material, you can certainly get those things in sooner rather than later. Okay. For Connections number 1, I have not yet posted the grades and comments and solutions because technically, so it was due this past Monday, it's technically open through this upcoming Sunday for late submissions, and not everyone has submitted this yet. So I don't obviously want to post solutions for this before people have had a chance to submit this, or to post solutions and then have someone submit it late having seen the solution. That's not really fair. Okay, so this will be posted. The solution file for Connections number 1 will be posted on Monday. I will actually post the grades and comments for those that have submitted this over the weekend so that you can at least see how you did, but the solution file will not be posted until Monday. Okay, I just want to point that out. Okay, hopefully you found that helpful. So again, the solution file for Connections number 1 will be posted on Monday, but I will post the grades and comments over the weekend for those that have submitted it. It is open through the end of day Sunday, so for those that have not yet submitted the first Connections assignment, you do have until the end of day Sunday to get that in for late submission. And then just a reminder for this upcoming Monday, I think it's Knowledge Check 4, assignment number 2, which is on modeling, so feature engineering and modeling with that Seoul, South Korea bike data set. And then the second of the Connections assignments. Those are all due this upcoming Monday. Just a note on the second Connections assignment, for this one, I'm asking you to use Microsoft Copilot to help code with creating a graph when we haven't yet covered ggplot. So the whole point is to kind of give you experience coding when you don't know how to code yourself for a particular thing. Get as close as you can. Don't spend more than a half hour on that. So I've had students that have spent like a couple hours. They get very frustrated. That's not the point of that assignment. The point of that assignment is to give you a little bit of the experience of coding. You'll find that it probably gets you most of the way there on the first attempt, but there are probably little things here or there that are different with your graph versus the graph that I've provided. Try your best to use AI to fix those things, but don't go down like a rabbit hole of like an hour or 2 hours of coding with AI. That's not the point of that, okay? Get as close as you can. You do need to use ggplot though, so do not, AI will probably default to using matplotlib. I don't want you using matplotlib, so you will lose points if your graph is using matplotlib. The second thing is don't simply copy and paste the graph into AI and show it the graph. The point is you're describing what the graph looks like to AI. Yes, if you copy and paste the graph into AI, it's going to get to the answer very quickly. That's not the point of this exercise, okay? So in the spirit of the exercise, do not give it the graph, describe the graph, tell it that you're using ggplot or you want to use ggplot, you're using Python, see what it does, have a conversation going back and forth to get it as close as you can. But again, don't kill yourself. Don't go above like about a half hour of time working on that. Okay. Have a great weekend, and I will see you next week. Bye-bye.